Okay, hello and welcome to another devlog. For this devlog, I did a few things. I wanted to do more things, like more things with the window manager, but I ended up doing just a few, and but a few important ones. So the first thing that I did is I replaced the use of Van.js with IMA. Now, IMA is a framework that I created. It's a reactive framework inspired by Van.js and inspired by immediate mode rendering of UIs. It is not immediate mode. It's just inspired by it and uses a few ideas. So let me jump on that first because if I just open everything at once, my computer freezes. So yeah. Anyways. So here I have a benchmark to compare a React version with my IMA library. But before I do that, let me just give you a quick overview of the app that we're building here. So here you'll see that we have this app element or component, and we're appending that to the body. This is a normal HTML element. There's no magic. We have our tags here, just like we had before with Van.js, and we have some global styles, and that's it. And then inside here we have our, our text and some reactive callbacks here. So anytime you see a callback being passed as a value to either an HTML parameter or a node, that means that it's gonna change whenever what the function returns is different. So yeah, here we are just rendering 20,000 buttons with some reactive stuff in them. So yeah, now this is gonna make this reactive. This is just showing the number. Okay, now the React application is set up to mirror that. We can also look at that. So here we have the styles as well. We have the app, we have a counter state, we have the render times, we have a ref to keep track of it, and yeah. We also have these 20,000 components, and we update the count. I just realized that this is using snake case, and it looks so funny to see React code this way. And then we have this use effect, which whenever the count changes, we essentially calculate the time difference between that. So it's not like a one-to-one comparison, because they essentially work in a different way internally. But it's a close enough value to understand, and you'll see how it looks on the actual testing. Now, the IMA library here, it's very short, it's very small. It has a static tag generator in case you want to do render HTML strings, and then we have this reactive setup, the reactive system. And the way that it works is that every frame, so every reactive callback that you set up, like this one for example, this is being called every frame, and that means that the HTML is going to be different, right? And so every frame we render all of those functions, and then we compare the results. We compare the previous HTML with the new HTML, and if there's difference, we just update the subset of just the parts that change. And you might think that might not be too a smart way of doing this, but as you'll see here on the React comparison, it actually is more performant. So now let's go to the tool here. Now this is rendering the last max milliseconds that it took for a frame. So if I open the tools here, and now let's open the FPS to get some reference. Now FPSs are not gonna update all the time, just whenever whenever the frame changes, essentially, right? So like here, moving the mouse because there's some change when I hover, you know, you get a sneak peek on how long it took. So yeah, so when you click on something like here, 48, now it tells us like, okay, the last maximum time that it took for that frame to render, which means to render everything that we're looking at on the screen, it took 17 milliseconds. And you know, we can click repeatedly, and it's pretty fast. I mean, it's like 24 milliseconds, so it's not too bad. Then you know, we can just like inspect one of these things. It's a little sluggish, but not too, you know, like it's manageable. And we have like 20,000 of those. So now we look at the React, we also have 20,000 of those. And I'm gonna click a bunch, and you see it takes some time, and it does, I guess it does something kind of like frame skipping or similar. Like it has a queue of events, and then it just like executes them when it thinks it should be done. I'm not a React expert, like an internals expert, but that's what I guess is happening here. And here we have the render time, which I wouldn't make it a one-to-one comparison, but it could potentially be. I mean, we do have about 38 FPS when we, well, actually less. It's like 19, well, 0, 20, yeah. So yeah, I mean, in terms of performance, it's actually quite good. You would think otherwise if you know, think about how much it's doing each frame. By the way, the cat is like about to do something. Anyways, so yeah, I mean, this is a quick benchmark to compare the two. Now, in terms of the API, as I said, it's pretty much Van.js without state management. Now, that's the key thing for all of this. It's very nice to just be able to use normal variables like this, you know, let count equals whatever, and then, you know, like whenever that changes, then that's good to go. You can also just, it's not that you have to use variables, it's like, you know, a reactive function is gonna render some text or some HTML, and if that's different, then it's gonna render that. And because it's doing it each frame, you don't need to kind of like synchronize different state parts along, like within your app. Like, it's just gonna render everything, and it's gonna use whatever state is available. And if that state is just variables and like just memory essentially, then there's not gonna be issues where, like in React or other like stateful frameworks, you know, where you can get desynchronized, right? And like, this is actually a common issue that I faced with making video games or like map applications, where, you know, like the code, like you have a canvas that's rendering something each frame, like a game or a map, and you have state that helps you, you know, manage interactions within that. Like, for example, where's my window? Let me close this now. So for example, if we go to Lane Rider, which is a game that I made, this is actually where I wanted to, this is what got me to building this library actually. Let me move away from the portal because it's very noisy. You're gonna see me play this. Yeah, that's fine. Anyway, so yeah, this is a game, you know, it's rendering some stuff every frame, and then also it has a, you know, like it's a stateful application, you know, you click here, then that state changes, and then you see a different representation of that state via the UI. This is using EMA. It's a slightly older version, but it's the same concept. And yeah, before using EMA for this one, I actually was using Van.js. And Van.js has an asynchronous state management system. And I was just having a lot of problems where I was unable to synchronize the game state, which is, you know, it's not asynchronous. It's actually quite synchronous with this other system, and it was a pain. And the same applies for React. Like if you try to use something like DexGL, for example, which is a tool to render GPU, like map visualizations. You end up like in a messy way, and I mean, not that this library is doing anything wrong, but like React and just any like reactive system that has like state management for reactivity, it's just not a good mix in my experience and in my opinion. It also overcomplicates your code unnecessarily. So that's the goal, behind my EMA library. And I mean, it's still very early. I'm pretty sure there's a lot of optimizations that I could be doing. Maybe more caching. But I mean, it's proven to work really well so far. So now if I move to the next point, I started migrating to Tailwind CSS. Now I thought about this a lot. And after thinking it, I like that you can be very expressive in a short amount of time. So, for example, let's open something real quick. Something that's using this. I haven't migrated everything. Well, let me just open this to begin with. Okay, let me also just close this here. No, it's good, it's good. Let's see, what things are using Tailwind? You can just do, let's also close this. Let's also do Tailwind. Okay, so the command palette is using that. So yeah, let's open that. I might have to get a little bit ahead of myself here. So we have this command palette component. And when you use this function, it creates the element and then it appends that to the body, or in this case actually to the main element here, and that's it. And here we're using Tailwind, and you might have noticed, if you know what Tailwind is, you might have noticed that I have this utility function here that I'm using to use these classes. And the main reason why I'm using that is because I'm actually using a custom build of the Tailwind CSS browser package. We can open that here in the browser. We can do Tailwind CSS browser. Yeah, let's look at this one. So if you ever fork this, when you build Tailwind, you also get this, which is this package, which is actually used for the playground. Tailwind playground. So this allows you to do, like stuff. It's gonna render something different. Yeah, I don't know if this actually works on real time. Yeah, it does. Anyways, so you see, like that's what it's doing. Yeah, let's get out of here. And if we look at the source code, it's simple. Like it's just it's just using the Tailwind library. Where it's loading like the default CSS not components, but like the templates, the CSS templates, like the reset CSS stuff like that. And here it's actually specifying like do not use this on production. And I'll show you why that is. Anyways, this library here is setting up a mutation of server, and then it lists changes to check for class attributes. So then it gets a list of class names, and then it passes those to the Tailwind compiler, and then it creates a style sheet on the DOM. Now we don't want to do that on our case, right? Like we don't want to set up a mutation of server to listen to that, and no, it's too expensive, and you don't want to do that with something like EMA, which you call that every frame. So the way to solve this is to use this wrapper function. So I forked this code and I implemented a function, and what this does is that it looks at all the classes that are being used and it just compiles them whenever you call that function. And when you call that function, you know, like it's gonna load it on demand, but once it does that, it's gonna cache that. So like it's not gonna it's not gonna recompile it every time that it changes. And in order to avoid unstyled changes on the UI, like for example, if you have like a conditional, you know, and then you have like you know, like some Tailwind class like this, you know, like instead like this. The problem with this way of having conditional classes is that the Tailwind compiler is not gonna take this if this conditional is false by the time that this function runs the first time. So if we want to prevent having to wait for this conditional to be true in order to compile that, instead of having this, we would do something like this, where we use, well, first we pass in an object, and then we have this key, and then we pass the condition. And so then, you know, because we're passing that as a configuration object, then it's able to read that when this function gets called, and so all of those styles get compiled, right? And that's it. And then, you know, like it appends the styles to the DOM. So if we inspect this and we look at the head, well, actually this here is not using Tailwind. But if we inspect something like the command palette, which, you know, gets me to the next point, then you'll see how it looks like. So the next thing is that I invented this concept called overlays in OM, and that is what I use to render this little command palette. It's a very minimal one. It doesn't do anything. It just has like 3 commands for this demo. And the first command is going to be inspect overlay. And this opens a new dev panel. And let's put it to the right because it's a bit annoying. Now, I'm going to try to inspect this. But because that has the draggable, the app regional drag that conflicts with it. But yeah, here we are using Tailwind for this overlay, and so you'll see that we have this tail tag, and you see that I have Tailwind here. It's actually, there's a bug actually. It appended it twice. I gotta fix that bug. But as you can see, we have the styles there, and we also have this, and you know, if I do this, then it changes. It sets the height to the full width of that, of this window. And then we can inspect this. Now it's full screen. Now, what this means is that this overlay is actually a different web contents view in Electron. It's not a new window. It's not a web view that lives within the web contents view. It's a different thing, right? Each window can have multiple children, view children, so you can have like overlays if that's what you need. So the cool thing, or what that enables us, is to have not only different processes on the CPU for those layers, but it also helps us with navigation, which takes me to the last point here. So if we want to navigate to a different space, and you know, let me show you what I mean by space. What do I need here? Oh, there you go. So this is the old version, and if we go to my lab room, you know, that's a different space, and so we navigated to this other space, right? Well, it's essentially the same thing. So if we go here, I can navigate to a new space, and it's called Earth. Now, something interesting about this is that a space doesn't have to necessarily be a canvas or a desktop. It can be a full screen app if you want to see it that way. It's just another space, and it doesn't have to render applets if it doesn't need to. So it can be anything that you want. In this case, I made this like Google Earth type app, and yeah, and then I can just like navigate back. And this toolbar here is actually not going to lose its state. If I go back, you'll see that we still have this state enabled there, you know. And yeah, and that just enables us a lot of utilities with navigation and stuff like that. So now let's dive deeper into this space here. So this was actually built with TypeScript. You know, so if you're new here, you might not know that this whole Electron app is built using JavaScript and no bundlers. And that's a conscious decision that I made because I want to make this application not require an additional build step to be able to customize it. I would love it to be TypeScript, but until Electron migrates to a full TypeScript setup or another tool comes by and I replace Electron, this is the way that it's going to be set up. So, you know, like on the system folder here, which is kind of like the backend or the Electron backend code, we have all this JavaScript code. And then in the user space one, we also have a bunch of JavaScript code and HTML as well. So here we have the overlays now, which has the same folder structure as the spaces. And so each space has an index HTML, which, you know, you can load CSS if you want, configure it in some way, and load the main script, which in this case, you know, we set up the applets that are available, and, you know, like the desktop initialization code for the canvas. And so here on this Earth one, you see that it actually has node modules, right? Because it's using TypeScript, so you have to compile it. And I also have this map libra dependency. So yeah, let me show you this actually on a different folder. So let's open this one and let's minimize this one here. Yeah. So, and let's also minimize this one for now. So here, this project is very simple. Now the idea of me, you know, using null modules here is to showcase that you have the freedom to kind of like create your own spaces in any way that you want or prefer. So in this case, if I am using TypeScript, the bundle that I do like to use is bun. It's very fast, it's very portable. It's written in Sig, which I like. So yeah, I have this bun build command that essentially takes this entry point TypeScript and it compiles it for the browser. And then we set up this watch. I actually have it running here. And so if we open this index.ts file, you'll see that we're importing IMA. And this $sign alias, it actually points to two folders outside. And if we open up this again, two folders outside means that we have access to this user space folder. So we can use any of these tools that are included here. We could even reference any other space or whatever. So you have access to those. And so here I'm pulling IMA, the JavaScript module, because, you know, it has to be JavaScript for this context. But I do have a types here that helps with the IMA types. So if I open up here, you know, I have this. It's just to get some better language server utilities on the editor here. So as you can see, restart language server. And now you see we have types now from those. So yeah, here we are actually using Telegram as well. We're loading that same library and we're using MapLibra here. So again, it's very simple setup. We have this main element, and then we append it to the body. We wait for it to mount, and then I create some other stuff like this utility function to calculate the atmosphere sun effect here. So here you can see like it kind of represents where like the time. It's not perfect, like it's not super accurate. We still have some light, but it's gonna and we're close to for it being noon, so it's kind of accurate anyways. And that actually updates we have an interval where we calculate that every hour. And yeah, then we have this map. So after the main thing is mounted, we calculate the first time, and we create a new MapLibra map, and with some configuration here, and then we wait for that to finish, and then we set up the interval, and then I add some UI, some reactive UI here. And what this is doing is it's just updating this, like the zoom. It's the zoom value, so whenever I zoom in, this changes reactively. So yeah, very cool. So yeah, I mean, this is how you set up a space. It can be anything that you want. Now there's a lot of things that I want to add. So like for example, routing, and having different screens inside this. Like if this is an app, right, and I want to show different screens or routes that the app can navigate to, that has to be implemented manually right now. And remember, like we're still in a browser, so you would need some kind of like client-side routing, because even though it's a browser, like it's not an actual browser. So the way that I have set it up is that the space web container doesn't allow remote URLs. So you can't load a website and render that website remotely, here instead of this. I mean, you could if you configure it that way, but I have explicitly set it so that you can't. And so like for example here, if I open this again and I move this and I click here, you see that it opens a new window. This can be configured so that it opens the host OS browser that's set up, or it could open a web view if you configure it that way. It depends, like how the space handles that, and like what's the setup for your whole OM system. But yeah, this is pretty cool. I could stare into this like for hours. So yeah, I mean that's pretty much it. I didn't do too many things. So yeah, next time I might continue working on some of these items, because I'm not fully migrated to Tailwind CSS. I have to update some of the styles here, like this thing here. This is not using Tailwind yet. These are not using Tailwind. But yeah, so I have to update some things there. And I would like to have a system kind of like Chatcn. So if we look for Chatcn, this is a React component library that has a way of working where you have templates, and so it copies code with your configuration instead of being like a separate library that you can't change. And it's a very good point of comparison. Like I would love to have all of these components within OM, so that anyone can just like very fast get started with a design system that's compatible with the rest of the system, but that also allows you to customize it. So that's the intention behind this setup. That would be pretty nice to have there. What else? Why is it like lagging? Oh, it's my mouse. Never mind. Anyways, yeah, I mean, I've noticed that I have some bugs the rendering. Like there's just a lot of work to do. And the way that I'm gonna continue working on this project is kind of like the way that Andreas Kling does with Serenity OS. Well, the way that he used to do it. Now he's more focused on the Ladybird project. But I remember in one video he said something like, "Oh yeah, like I just want to work on the things that I like, and I'm not gonna make this something that I, like feels like a job or something." He said something along those lines. So I want to follow the same approach where I just don't want to like force me to work on things because they are required, but rather like have fun working on this. Like there's a lot of things to do. It's a big project, so I might as well just work on the things that I like first. And yeah, I guess that's it. I'll see you in the next devlog.